So the last section that we're going to cover for this test is Chapter 6, Section 6, Systems of Inequalities. Go ahead and try and solve this system of inequalities by graphing. Press play when you think you have an answer. Okay, so for systems of inequalities, remember, we're going to graph these just like we graphed inequalities in the chapter before. We're going to test a point and shade the appropriate side just like we did in the chapter before. And since we have a system, to find our solution, what we're going to do is we're going to look for shaded portions of those two inequalities, and if the shaded portions overlap, that's the solution. If there's no overlap, there is no solution. So let's take a look here. So these ones are already set up with y isolated, which is great, makes it nice and easy to graph. Okay, so right here, I have y less than or equal to 5. Since there is nothing else here to go off of, we go up 5, 1, 2, 3, 4, 5, and right there, we're actually going to mark right across y equals 5. Now, remember, this is less than or equal to. Because of that equal to, we're going to use a solid line. If it was just less than or greater than, it would be a dotted line. Hopefully you remember that. Now let's test and see which side of this line we shade. So I always recommend the origin 0, 0 as a plug-in point if you can. So if we plug that in, we end up with 0 less than or equal to 5. We ask ourselves, is that true? Well, yes, 0 is less than or equal to 5. So that means where 0 is, we are going to shade in that portion. So this portion gets shaded in right there. Next, we have y greater than x minus 4. So I go from the origin 4 down, 1, 2, 3, 4. And since I don't see a number here in front of the x, I assume the coefficient's 1. To make that a fraction, I put it over 1. So our slope is 1 over 1, or 1 up and 1 to the right. So 1 up, 1 to the right, 1 up, 1 to the right, 1 up, 1 to the right, and so forth. You get the idea? Now, since this says greater than, not greater than or equal to, just greater than only, we're actually going to use a dotted line. Make sure you're using the correct line, and we learned about this in the last chapter. So now we test which side of this we shade. Notice that this right here, when we tested that, it covers this entire area. We need to try and find out if there's overlap. So if we plug in 0 and 0, we end up with 0 greater than 0 minus 4. Simplified, 0 is greater than negative 4. 0 is greater than negative 4, so we're going to shade where the 0 is again. So for this one, we're not going to shade on this side, we're going to shade on this side of it. And the spot where the two shaded in portions overlap is right here. So this whole shaded region would be our solution. Not above it, even though our solution test tells us everything above this this inequality is shaded, and not below this, even though our test for this tells us everything below is shaded, just right here where the two shaded regions overlap. Now, one thing I do want you to be aware of is when you're doing the test, if you come up with something like this, suppose I have this here and I have dotted or solid, it doesn't matter. If when I do my test, if this area ends up being shaded for this inequality and this ends up being shaded for this inequality and the lines are parallel, the way you can tell they're parallel is they will have exactly the same slope. Here they just have a different y-intercept, same slope, different y-intercept. If that's the case, then the graphs will never overlap, so here there would be no solution. Alrighty, and if you understand all that, you should be pretty well set for the test. Don't forget to do the practice questions, and we'll see you in class.